Okay, so yesterday we talked about number 1. You had to plot 7 points. Do not connect them with lines. I'll remind you on test day that same instruction that you're plotting 7 points and nothing else. No other lines. And set up a table for that. Number 2, use your table. I'll just have a table that I'll pull off my calculator. I'll ask you a series of questions about it. Same type of thing. Make sure that the only thing I'm going to warn you of tomorrow is make sure that you know if you're using Y1 or Y2 or Y3, whatever one you're doing, whatever one it asks for. Make sure that you're paying attention to like what the question is asking for. So like, is this one function past the origin? So you got to be careful with that. Okay. Number 3. We did that one yesterday. This is the one we ended with. And that one was one where you had a series of questions. Remember, the type of question I'll add to that could be a maximum or minimum of what type it is. That'd be the only other question I could probably add. So yeah, so just be kind of cautious of that one. And then make sure that this bottom question, I always have a lot of questions people always ask, is like, it's these two. You're finding the answer, like where the graph actually hits. You've got to be within a certain boundary. So like yesterday we talked about like the number 2 here. Number 2, the answer was -5. A lot of people say -4. It's got to be within, usually I say like within a half, because some of them are like questionable. Like when you get to -2, it's kind of like 3 or 3.5-ish. So it's got to be within the ballpark, and I give it to you. But the one thing I'm worried about is don't say like on 2, don't say it's -infinity. Like that was one of the things I think we were talking about yesterday. It's like you got to give me the number it's going to hit, not a direction. So. Okay, any of the questions from the 3 yesterday? That was just a quick 2-second review. Perfect, let's move on to the hard stuff today. We gotta get to number 4. Okay. 4 and 5 are the 2 problems that you're gonna want to take the most time on tomorrow. Because they're worth a lot of points. I know like number 3 is worth a lot. There's a lot of questions there about that thing. For this one, there's a lot because you have to graph it yourself. So I'm looking at, are you graphing correctly? Are you using arrows? Are you using dots? Are they filled in? Are they open? You know, did you make a rough, you know, like a very like pretty well done sketch, that type of thing? Then you have to make sure that once you have these drawn accurately, because it is going to be a piecewise function, are you answering the questions correctly? And there's a series of questions. So what I warned you yesterday is like, if you draw really bad, all your answers below that are going to be bad. So like it's going to compound and it's going to look bad. It's going to look worse as you keep going. So just be careful with that. I do give a little bit of leeway on certain things on the graph, but do it as accurate as possible. That's all I can tell you, so that you get the right answers. Let's go through this so you can actually see this. In fact, I'm going to zoom just a little bit so we can actually. Okay, let's draw this first, and then we'll get to the questions. I'm sorry, like I zoomed in, so I won't be able to read those bottom questions because if I move, then this graph will go away. So I'll ask you guys for what those 4 questions are. There's series 4. I know the first 2, but I don't know the next 2. All right, let's draw the first one. We're starting at what point on this first graph? 1. We're going to start at 1, and that'll be an open circle there. The reason why it's an open circle is because I don't have a little bar underneath this. So we're going to plug in 1, and basically what I'm doing is I'm setting up like a little table over here for this function. This is the -12x². I'm going to plug in 1, and I'm going to plug in all the numbers that are below it. Technically I'm going out of order here, but I'm going to plug in 0, I'll plug in -1, -2, -3. I'm just going to plug in a few numbers. I don't know where this thing's going. I know it's a curve. So I got to kind of see which direction is it going. But I'm starting at 1, and that'll be an open circle, and yes, that table is drawn backwards, sorry, because it should be least to greatest. All right, plugging in 1 squared is 1, and we take that times -12, I get -12. So -12, in fact, let me put the dot there. So 1 over -12 down, that's an open circle. So there you go. Again, it's an open circle, you're not allowed to include 1, so that's open. Now, going off the next number, plugging in 0, 0 squared is 0 times -12 is still 0, so that's 0, 0, and that's a solid dot. Because once you pass the first number, you can use all the rest of them. Let's plug in -1. -1 squared is 1. T times -12 is -12. Guys, come back to -12 again. So we're starting to see it is curving. Just a little loop here. Negative 2 squared is 4. You take that times negative half, you get negative 2. So negative 2, negative 2. And now we're starting to see where this thing is going. Negative 3 squared is 9 times negative half is negative 4.5. So negative 3, negative 4.5. Yeah, we can get a sense this thing's going this way. I'm just going to stop there. I think you get the idea. Okay, questions with how I did that and why I did it that way. That was just the first graph, correct? Yeah. Okay, second one. What can you tell me about the second graph, this one that I'm doing? I'll do it in a different color, but what can you tell me roughly about this? Say? It's linear. It's a line. The reason why? No powers. No powers at all. It doesn't have like a square, a cube, nothing. So it is a linear problem. It's going to be a straight line. So once I know that first dot and I get the second dot, I'm pretty much done. I know it's going greater than or equal to 1. So that is a solid dot for sure. It has a little bar underneath it, so I can fill in that first dot. So that's kind of nice. There might be actually a little bit of overlap here. So that's probably the reason why they had one open, one closed. So if I plug in the number 1, and again, I'm going to make a little table again. So my function is 2x plus 1. Right? Plug in the number 1, and then I'm going to plug in numbers that are bigger than that. I really don't need to go that many. Pretty much only need 2. Plug in 1, what do I get? 2 times 1 plus 1? 3. 3. Plug in 2, 2 times 2 plus 1, that's 5. 3 times 2 plus 1, it's going up by 2's. So, okay, 1 comma 3, that's a solid dot. Because again, you're allowed to use the first number because it would have a little bar underneath it, so it's a solid dot. 2 comma 5, 3 comma 7, 4 comma 9, and you get the idea it's going that way. All right. Do we feel comfortable with the drawing? Okay, good. And again, it could be, a piecewise where there's 3 items, it could be 4 items. Just graph whatever ones they are. I promise you, I'm not gonna pick ones that are crazy difficult. I'm not gonna do that to you. But you have to be able to draw. Okay, so now that we have our sketch, now we can go ahead and answer the question. So the first question, what is the function's range? We're not going domain, we're going range, y numbers. So what's the lowest y number I can hit? Negative infinity. Good. So we're starting at negative infinity and we're working our way up. Negative infinity, working our way up. Eventually we stop at 0. Has a peak of 0 there. 0, and that's included. There's a solid dot there. Notice I didn't say like negative half because that was actually included earlier. But I hit a peak of 0. Then there's a gap. So I'm going to have to do a union, and I'll have to pick up where the gap leaves off. Where's the next spot that I hit? 3, that's a solid dot. Positive 3, you don't need to put plus, I just put that in there. I just wrote a negative. So positive 3, and then we're going up to what? Positive infinity, and that's a parenthesis. There's your range. The big thing I'm looking for in range, if there's gaps, are you doing unions correctly, unless there's overlap? Are you using parentheses and brackets correctly? That's things I'm checking for. Okay, notice, you're using the y numbers. I'm going least to greatest. Small number to big number. Small to big. That's how it always works. If you flip it around, I do count wrong. It's got a least to greatest. All right, questions on the range idea. Now, if it were to be level, let's say it was flat. So let's say your graph was something like this. I don't know if we talked about these yesterday. Let's say your graph is something like that, very similar to that. Let's say this is 1, and it was narrow. But let's say 2, let's say this is 3 again. Let's say it was flat here. And that's an open circle. And it wanted range. Okay? That's a terrible number. So that's 1.5, sorry. Okay, so range would be from negative infinity up to 1.5, including that one, because that's the number I hit here, 1.5 is peak. Then I'm going to do a union, and now it's flat, right? You would just put a number, and it would be included. That's how you do it if you actually had a number and it didn't go past that. It's just one single digit. You can just put the number in a bracket. You're allowed to do that, because that number was included. Does that make sense? Like if it doesn't go past that, if it's like flat? All right, are we good? Perfect. Okay, let's go to, Abby, we're just doing problem number 4 here. Start with that one. So try to get the graph as best you can here, and the tables, one of the tables. Okay, 3, state the intervals where we're increasing, decreasing, being constant. Looks like I don't have any constants. So this answer number, I guess is part 2 of this question. I would label each part. So I would say like this part is increasing. This part's decreasing. And this part's constant. Like I would separate out and see if I have any. Well, on my graph, is there any constants? Is there any flats? No. So this is like non-applicable. NA. Doesn't work. We don't have it. We definitely have a spot where it's increasing. There's actually 2 locations where we're increasing. We're not going down. We're going up, like from left to right. We are climbing. Can anyone give me the interval where we're just going up? Give me X numbers, by the way. So where am I going up to the right?
Negative infinity to 0.
Negative infinity to 0, good, okay. I'll only write that down. So negative infinity up to 0, now that's, we're gonna put a parenthesis here, which I know is really weird, because that 0 is actually being shared with a decrease, because it was like a hilltop, so you can't include it. Then we have a union, because then it starts to climb again at what point? 1. You have to use X numbers. Okay. So we're going to start at 1, and we're going to go up. And 1 is actually a bracket. The reason why the 1 is not shared with the decreasing side. It was actually like it was a starting point, so we use a bracket of 1, and it goes up to positive infinity. That's pretty much the time when you use a bracket is when you have an end cap. When you have an endpoint, that's when you can use it. Okay, questions on the increase. Left, right, and use X numbers. Use X's. Okay, what about decreasing? Where's it going down? 0 to 1. 0 is in parentheses. Even though I know it's a solid dot, it was shared with the increasing and decreasing side, so you can't allow that. So 0 up to 1, and 1 is also in parentheses because it was an open circle. You can't include it anyway. But there you go. And it wasn't an intervals, or it wasn't a union. There wasn't any breaks. Okay. Constants, you still use X numbers. So like from 15 up to positive infinity. Maybe it's constant. Like this one, the constant domain would be from 0, like in parentheses 0. Towards positive infinity, because use the X's to state where it's constant. If you're doing that, this is the domain if you, or range I should say, if you have for constant. Okay, questions, comments about the 2 types. Now down below, 3rd question. Does it ask for min and max? What is that 3rd question? Min and max. Yeah. This one does have a relative maximum, which I know is really weird. Because I know, like, you're thinking, well, this thing goes to infinity, but it does have a relative max. Relative maximums or relative minimums are where they have hilltops. It's not like an endpoint. We don't consider those relatives. It's where you have, it goes from like increasing to decreasing, or decreasing to increasing, or it like swoops. So where is this little hilltop at? Origin. Yeah, the origin, 0, 0, you would have a relative maximum there. There's no absolutes in this problem because this thing goes to positive infinity and negative infinity, but it does have a relative max. So like on that 3rd question, sorry, I can't scroll because I have a loose graph here. You would actually say relative max 0, 0, like put the coordinate. You don't, if you want, you can write it doesn't have an no absolute max, no absolute min, no relative min. I know like a lot of people always want to state these endpoints. But they don't count. It's got to go from increasing to decreasing slope, or decreasing to increasing. It's got to be like a hill or valley to be considered a relative. Okay, questions on the peaks and valleys. Is there any other question that it asked for? No? Perfect. Okay. It's going to be something very, very, very similar on the test. Basically, all I really did was was pick a new function, one that was in your homework that you had, where you had to do a piecewise function. Is that the page 175 step? The 46, 47, 54, I think those were piecewise, the last homework. So I just picked one of those, and then basically the same thing, very similar questions. It could ask for domain, it could ask for range, it could be increasing, decreasing, or constant, and then a min-max kind of question. All right, I'm worried about that one though. If you draw it wrong, you get pretty much everything wrong after that. So be careful, draw the tables, so that way you can plot your points, and make sure that you're using the correct numbers. Okay, let's move on. Sorry, I spent a lot of time on that today. We had to make sure we knew every in and out of that problem. Especially if there's constants, like how to do range and stuff on constants. Because I don't think we saw any of that. All right, let's move on. Let's go to number 5. We gotta spend some time on 5 too. Okay, this is the other problem that I kind of warned you of, that this will take you a while just because of the level of difficulty that's involved here. This might be one of those problems you have to use the back page of your practice guide. So if you're gonna use the back, maybe you want to start it here, and maybe you just you're running out of room, go to the back and just say put on the back. Just write that down in words, and you're gonna go on from there. Some people make it fit. You have really good penmanship, it's really small. I don't. My penmanship's huge. I usually have to use the back page on this one. But this is the formula that we have to use. This is called the differential quotient. We had this in page 172 assignment that we had. You have to take the function I give you and plug it into this thing. So this is the function I'm going to be using, and we have to slightly modify this thing and plug it in here, and then simplify it all the way down until we get down to what the slope is. Because that's what this differential quotient gives us. It gives us slope. It's difficult. It takes a long time. You have to FOIL, and you have to do other things and simplify and divide by h. If you can get this set up correctly, you're going to be fine. The setup is always the part that most people, they just don't know how to start it. So to get to the starting point, we have to write this function down, but you have to put an x plus h into it wherever there's x's. You're substituting in an x plus h. So here's what it's going to look like as the start. So you're going to have the h on the bottom, right? Because you have the h here. You're going to have the function, but x plus h's are plugged in here. So this is what it's going to look like. Negative x plus h squared plus 2x plus h's minus 1. There's the function with x plus h plugged in. Does everyone see how this is supposed to use this thing? Wherever there's an x plus h in there. It's the same function, negative 3 squared plus 2 minus 1, right? And then now that we have that part's done, check, that's written down correctly. Now we're going to subtract the original function. So now we're going to subtract the 3x squared, that's a negative 3x squared, plus 2x minus 1. We're going to subtract the original function off. All right, questions on how I did that? All right, now from here on, this problem, this is what takes the longest time. The setup is tough for some people because they don't know how the x plus h thing works. But from here on, you're foiling, distributing, you're doing everything you need to. Remember, on this first part, this part right here, how do you deal with the square? What's the correct math that's involved? Say it? Foil. You don't distribute. Don't distribute, stupid 2. It's 2 parentheses foiled together. So it's doing this. That's what you're actually doing in that first part. Then you have that plus 2x minus, then we distribute this negative sign to the back. Yeah, I know I'm repeating that same thing I just wrote down, but I want you to see that. That's this thing right here. You have 2 of them, that's why you have to FOIL. First, add, and last. That's what the definition of a square is. Definition of an exponent. Okay, questions on how to do it. Now, when you actually start to simplify, and you get down to your final answer, and eventually it turns out to be something like this. Okay, there's some work in the middle. Eventually you're going to get down to negative 3x squared minus 6x h's minus 3h squares plus 2x plus 2h minus 1 plus 3x squared minus 2x plus 1, right? Blah, blah, blah. That's after doing a couple lines of work in my head. Okay. Once you're here, things start to cancel. Here's how you know you did it right. If you had the setup right and you FOILed correctly and you distributed numbers and negative signs correctly, all that good stuff, things that don't have h's will cancel out. So that's how you know you did it correctly. So when I look at this problem, negative 3x squared, that doesn't have an h, it literally cancels later. Or the 1 doesn't have an h, that cancels. The 2x's canceled. Anything that doesn't have h goes. It's gone before I even get to dividing by h's. Because there's still an h on the bottom, right? I haven't even got to that part. There's an h down here. So once you're here and you've kind of simplified everything, this is where I'm at so far. Negative 6xh minus 3h squared plus 2h. All right. You're going to want to divide everything by h. Just cancel out one h and that's your answer. Your answer will not be a fraction. You'll be able to divide everything by h's. So there's no fraction left. And then just that's your answer. That's all I want. Questions? Okay, this problem takes a long time. Like I skipped steps. I don't want you to skip steps. I wrote that down so you can see what the answer is going to do. Try to show me how you're foiling, what you're doing, what answers you're getting, how you're adding things together. That's why you might need to use the back. My penmanship is terrible.
Why is it -6x each?
When you FOILed first outer and last year, it's like x squared, xh, xh. There was 2 xh's in there, and then I distributed a -3 over it. So -3 times 2 is -6. Yeah, it's that xh and hx thing can add. Okay, any other questions? That was good though. Any other questions about that problem? Take your time on that problem. You need to get the setup. If you're one of those people like, yeah, I don't get that problem, you need to like ask a question. Maybe when we're done today, I can put up a problem up here. You can try it out on the marker board. But this is worth a lot of points, like a stupid amount of points. Same with number 4, because there's so many like little things you have to do to get points on. They have to do correctly, and how I do want to see the setup and how you're going from there, that type of thing. I think last year this problem turned out to be like 8 points or something like that. Like it's not one of those problems you want to skip because it's worth quite a few. Okay, questions at all? Okay, let's move on. 6 and 7 are easy. I'll go back to the easy questions. All right, so now we're going back to linear equations. Now on the board, it will actually be on the back board tomorrow. I think you guys will be facing this direction tomorrow. For this type of problem, you have to write it into different forms, point, slope, and slope-intercept. They will be on the board back there. They will be clearly labeled which one's which. I'm just going to put them on the front board so you can see them today. So the 2 forms we're going off of, 2 forms. First form is point slope. This is point slope, by the way. And it'll be labeled on the board. Like that. There's your first form. That's my go-to version when I have information. I want to take it and plug it into the formula. Then to rearrange, we got to get the slope-intercept. Okay, slope-intercept y equals mx plus b. Okay, there's your second form. Okay, you start with the first one and we work our way down through the others. I will have them on the board tomorrow, like over there, and they'll be kind of in order. Point slope, slope-intercept, standard, general, the special cases. All right, first thing, if we're gonna go to these forms, what do I need? Say it?
Slope.
Slope. We gotta find slope first. We have to have that because that's gonna come up later. The next thing we'll have to have on this is just pick one of the two coordinates. So right now I can get like 90% of this problem done in the point slope form because all you have to do is find slope in the coordinate. Pick one of those coordinates right now. 3, 5, or 8, 15?
3, 5.
3, 5, perfect. We're gonna plug the 3, 5 in here. So this is what it's gonna look like. Y minus the 5. We're gonna find slope here in a second. We'll do that. And then x minus the 3. Remember, this goes with the x, this goes with the y. They're in alphabetical order. That's how I know where the numbers go. If they're negative, you subtract the negative number. So it eventually turns out to be positive. Does that make sense? You would not believe how many people put the numbers in the wrong spots. Y goes with y, x goes with x. And you get to pick one of the two. I don't care which one you pick. If they only give you one coordinate, fine, go with the one coordinate. Okay, now that we have this, we have to find slope formula. That will be on the board too. You'll have the slope formula. Here it is. You have to subtract the y numbers and then subtract the x numbers to find slope. Well, the y numbers are the back numbers. The x's are the front numbers. So we're gonna, and I don't care the order you subtract because it will always be the same answer anyway. I'm gonna go to 15 minus the 5 row. That's just what I'm gonna do. So I'm gonna subtract the y's on the top. So 15 minus the 5. On the bottom, I'm going 8 minus the 3. That way I can find my slope. My slope turned out to be, what is that, 10 over 5? Which turns out to be 2. Nice. So it's a nice number. So that's the number you plug in here. So boom, check mark. Number 1, you found point slope form. Now if that was a fraction, so be it. That's a fraction. Maybe it's 3 over 4. Fine. Plug right there where the 2 is. 3 over 4, x plus x minus 3. Now to get to this other form, slope-intercept, you have to simplify this thing. That's why this is my go-to version. Because if I distribute the 2, and I add the 5 across, now it's in this form. Because I just have to get the y by itself. Now, if that's a nasty little fraction, fine, you're taking the fraction times x, the fraction times the 3 in the back. You know, if this was 3 over 4, 3 over 4 times 3 is 9 over 4. Because you just take the fraction, and you take this whole number times the top. That's how I do it. So if it was 3 over 4, 3 times 3 is 9, so it's 9 over 4. That's just how it works. And you can make it a decimal if you want to. I don't expect you to. You shouldn't have to. So, we distribute. Here's what we have. We have minus 5, we have the 2x minus 6, and then you add the 5 across. That's your answer. That's how you get to it. Makes sense how you're going to do that. Now, if you had to get the standard, I'd have to move the 2 over to the y side, so it'd be a negative 2x. But again, you're going to have to finish that one on your own. Makes sense what you're doing there. Make sure if you have fractions, you do the fraction stuff correctly. I shouldn't have to go through how to add and subtract fractions together. You should know how to do that stuff. Okay, we're good? Moving on. Let's go to 7. Okay, number 7. If you read the directions here, we have to graph it, and we have to go to slope-intercept form for this information. So that's the part that a lot of people forget. Like a lot of people, like on the previous years, that have always had the similar types of questions. A lot of people draw it, and then don't give me any formulas for any of the problem. So you missed a bunch of points here. There's 2 different lines that are happening here. You have the original line, and you have the one that you have to be perpendicular to, okay? Or the one that is the perpendicular. So I'm gonna draw, so we're gonna be graphing a line of f passing through negative 5, 6. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Okay, so this is my negative 5, 6. I have to pass through that dot. It has to pass through that dot, but it has to be perpendicular to the next line. I'm going to put the next line in, I'll put it in green here. I need to be perpendicular to a line that has an x-intercept of 3, namely 3 times 0, and an intercept of negative 4, a y-intercept of negative 4. So I need to be perpendicular to 3, 0, negative 4 for the y. I have to be perpendicular to this thing. Okay, that's not bad. Like being perpendicular to that thing, all I really need to do is figure out the slope of the green line and then flip it over, making it opposite. Because if it says perpendicular, whatever my slope is, now don't write this down, this is just a mock example. If my slope turns out to be positive half, I have no idea, don't write that down. But let's say my slope is half for that line. Then my slope for the perpendicular is you flip it over and make it opposite, make it a negative. That's what we're going to be doing here in a second. It's not half, I'll figure it out here in a second. Does that make sense what we're going to do in my problem? Because perpendicular is, it's called an opposite reciprocal. You flip it over, make it an opposite. All right, but how do I find the slope of the green line? Yeah. Subtract the x's, subtract the y's, and y's have to go on top. So -4 minus the 0, 0 minus the 3. Again, how I did that, I'm subtracting the y numbers. I'm putting them over the x. I went back, front, back, front. That's just how I did it. So it turns out to be -4 over -3, which is 4 over 3. All right, that's the slope of that line. Right, it's 4 over 3. So what's my slope going to be? -3 over 4. Right. All right, so my slope for the perpendicular, so the slope of the perpendicular is -3 over 4. We flipped it over. That's the slope. That's my m for my perpendicular line. And now I have to come up with the equation for it. So guess what? It's this problem now has just turned into the exact problem we just did in number 6. I have a dot that I have to pass through, -5 times 6, and I have my slope. It's the exact problem you just did earlier, where I'm going to plug in my information in here, and then rearrange it to get to the other forms that they want me to. I think they want me to get to slope-intercept. Now, I can already draw this thing. I can already tell you where this thing's going, because I'm dropping 3, running 4, dropping 3, running 4. Boom, there's my drawing. And again, how I did that is, this is my rise and run. So I can draw that pretty easily. Just by knowing the dot I have to pass through, I draw 3, run 4. So the drawing isn't the bad part. It's the stupid equation part that gets people. The funny thing is, it's just number 6 again. They just happen to give you what the slope was. So making this formula out, going off of that formula, y minus, what's the y number I'm using? It's 6. My slope is -3 over 4, and my x number is the -5. I'm subtracting the -5. Makes sense, like how I plug those in? -5 and 6, and that -3 over 4. So this is the part where you're going to have a nasty little fraction. Fine, I'm dandy. This turns out to be a plus, by the way. All right, so I distribute the -3 over 4, because I got to get the slope-intercept right. So distribute the -3 over 4, so -3 over 4x. Multiplying -3 over 4 times 5 is -15 over 4, because you take the 5 times the 3 on the top. And then the last step is add the 6 across. So if I add the 6 across, like that, add it, just make it a fraction, and then get common denominators and add them together. So if that's 6 over 1, what's the common denominator to add these two together? 4 is on the bottom. So if I put a 4 down here, that's going to turn out to be a 24 up here. So I'm going -15 plus 24, is that -9? There you go, there's your equation. And did that number make sense? -9 over 4, what is that? 2 1/4 roughly? Positive, sorry, positive. What am I doing? Amateur hour here. Thank you. All right, positive 9/4, sorry. So when you look at the picture, did it rough, because that, in slope-intercept form, this is your slope, that's your y-intercept. 9 divided by 4 is about 2 1/4, 2.25. So did I hit 2.25? Yeah, it's about right. That's roughly where I'm hitting, about 2 1/4 for the y-intercept. And I dropped 3, ran 4. So the graph is actually telling me that these numbers are correct. Now, without doing that math, I never would have figured out that decimal. Like, I can't look at that graph and go, oh, it's 2 1/4. I can't do that. Like, it's not exact. So in doing it this way, I know exactly where that y-intercept is, and I know exactly what my slope is. 7 is worth quite a few points, as you can tell. You have to draw both things. You have to draw the original line and the thing you're going through. If you have to be parallel, the only difference is I don't have to do this stupid thing where I flip slope over and make a negative. Parallel, I just use the same slope, 4/3. You just go from there. And you do the same work. You plug 4/3 in here. You have your coordinate you're passing through, and you just distribute the 4/3 and do all the math from there. Okay, questions on 7. Okay, test is tomorrow. Be aware of that. I'll make sure the day after school I'm going to have all those videos from yesterday and today. I'll make sure they're online. I think yesterday's videos, I think, still up there. So, I'm going to make sure they're online so you can watch those videos. I'll try to do that right after school because I know some of you like have lots of stuff going on. You don't want to wait till late at night to watch those videos at some more time. Practice guide. That thing is due tomorrow. Get it done, wrap it up, do whatever you need to. Let's get it finished so you can turn it in tomorrow. Study tonight. If you're that person that's fearing that you're going to lose it, leave it here. If you're going to lose it, because you have to have that thing through. Be ready to go. Tomorrow I'll have that test, and we're going to be going right at it.